Hello students, I am Sonali Kelkar from City International School, and today we are going to do the in-text exercise and the back exercise question answers of the chapter Structure of the Atom. So let's start with the session. Let's see the question number 1. What are canal rays? Now, as we all know that canal rays are the rays that arise from the anode. What is anode? Anode is a positive electrode, and this is a discharge tube. Okay, in the discharge tube there are two electrodes. One is the positive electrode, which is called anode, and the negative electrode is called cathode. Very important, you have to keep this in mind. And this discharge tube is filled with gas. It is filled with gas at a very high temperature. Temperature is very high and the pressure is very low. At the high temperature and low pressure, the gas is heated. Gas is heated inside the discharge tube, and what Goldstein observed that a positive charge ray, okay, a beam of positive charge ray is coming out from anode. Okay, so in other way, anodes or the protons are also called canal rays. Okay, remember the other name of proton is also canal ray. Why it is canal ray? Because it is made up of positive charged particles. Okay, so canal ray are positive charge radiation which led to the discovery of positive charge subatomic particle. Why I am calling it subatomic particle? Because we know that atom is the basic structural unit of any element, and inside the atom there are still some things which are known as subatomic particle. Okay, proton is one of it, electron and neutron. Question number 2. If an atom contains one electron and one proton, will it carry any charge or not? See, the charge of proton, one proton means it has plus one charge, right? One electron means it has minus one charge. So plus and minus with the same magnitude will get cancelled, and finally there will be no charge, right? So the atom will be electrically neutral. How is the atom? Atom is electrically neutral. Let me change the color. Okay. Now question number 3, on the basis of Thomas model of an atom. You remember the Thomas model of an atom, where it is a watermelon. It is compared with watermelon, and it is also compared with the custard. Okay, a watermelon, in the red part of the watermelon, how the black seeds are embedded. Similarly, in an atom, the negative charge, the black seeds are nothing but the negative charge electron which are embedded in the pool of a proton. This was explained by Thomas model. J.J. Thomas model, very important. Go through the model. That is given in your book. Go through it and read it properly. Thomas model of atom explained how the atom is neutral as a whole, right? This is the very important discovery of Thomas. Thomas put a very important theory that atoms are neutral, and why they are neutral, that also he explained. An atom consists of positive charged sphere. The red part of watermelon is completely a positive charge, and the electrons are embedded in it. Electrons, nothing but the black seeds are embedded in it. The negative and the positive charge are equal in magnitude. Okay, the negative charge and the positive charge are equal in magnitude. So the atom is electrically neutral. This is what put forth by Thomas. Question number 4. On the basis of Rutherford's model of an atom, which subatomic particle is present in the nucleus of an atom? Okay, so we are going to anyways discuss the Rutherford model in detail. Here I am just going to answer the question, that is, which subatomic particle is present in the nucleus of an atom? It is a proton. Okay, it is proton which is present in the nucleus of an atom, subatomic particle. This is put forth by Rutherford. We know that in today's date, we know that the proton and neutron are also present, but neutron, the discovery of neutron was made later, right? Yeah, here you have to draw the sketch of Bose model of an atom with 3 shells. So here we can see okay, in the center there is a nucleus, and then afterwards we have shells, 3 shells. So here they have given 4 shells. It's okay, even if you draw 3 shells is okay, even if you draw 4 shells is okay, but 3 has to be there. Don't end up by drawing 2 shells. K shell, L shell, M shell. K, L, M. These are the alphabets, letters, English letters given to the different shells. K, L, M. Okay. So this is what is Rutherford model. Question number 6. Name the 3 subatomic particles of an atom. We know that protons, positively charged, electrons, negatively charged, and neutrons, they don't have any charge. So these are the 3 subatomic particles of an atom. Very important question, can come for 1 mark. Next question. Helium atom has an atomic mass of 4U and 2 protons in its nucleus. How many neutrons does it have? Now we have to start with the atomic mass. What do we mean by atomic mass? Atomic mass is number of proton plus number of neutron. Okay. Now in this case we know that atomic mass is 4, that they have given. Number of proton are 2. What is the number of neutron? Okay. So 4 minus 2 is 2. 2 are the number of neutron present in the nucleus of helium. Okay. Okay, now coming to the next question, write the distribution of electron. Now what do we mean by distribution of electron? Distribution of electron is nothing but the electronic configuration of an element. Electronic configuration. Okay. And very important to know electronic configuration. Now what do we mean by electronic configuration? That means distribution of electron in different shells. Okay, what are the different shells? K, L, M, N. K, L, M, N. Now to distribute the electron in the different shells, we should know the atomic number. Okay, here they have given carbon. So what is the atomic number of carbon? Atomic number of carbon is 6. Okay, fine. Now you have to distribute 6 electron in the shells. For that we should know, according to the Bose model, we should know that number of electron that can be accommodated in the shells. The maximum number of electron that can be accommodated in the shell is given by the formula 2n square, right? 2n square. So as K is the first shell, I can write 1, 2, 3, 4. I have to give number to the shell because I am using a mathematical calculation or mathematical formula over here. K is the first shell. So instead of n, what is n? N is the number of shell. So 2 into 1 square. So now maximum number of shells, maximum number of electron that can be accommodated in first shell is 2. So I have filled, out of 6, I have filled 2 electrons in K shell, right? So how many electrons are left with me now? 4 electrons are left with me. Now let me see whether I can accommodate all the 4 electron in the L shell. Okay, now what is the maximum number of electron that can be accommodated in L shell is 2 into, what is the number of the L shell? 2. So 2 into 2 square. 2 square is 4. 4 into 2 is 8, right? So I can accommodate 8 electrons in the L shell. Now I am left with 4 electrons. So definitely the 4 electron will go to the L shell. So this is the electronic configuration of carbon. Similarly, you have to do with the sodium. Sodium, okay, sodium has atomic number 11. You should know from 1 to 20 atomic number of all the elements, right? So 11 in first shell, 2 will come, right? What is left over? 11 minus 2, 9 electrons are left over. Can I accommodate 8 electrons in L shell? Yes, the maximum number of electron that can be accommodated in L shells is 8. So I have accommodated 8. So 8 plus 2, 10. Okay, now 11 minus 10, 10 electrons I have already given the position. Now 1 is left. That 1 will go to the shell M. Right. Now what is the maximum number of electron that can be accommodated in M shell? That is 2 n square. Instead of n, I'll write 3 because 3 is the number of the shell. 3 square. What is 3 into 3? 9. 9 into 2, 18. Clear? So this is how you have to go through. Okay, so you can learn the maximum number of electron that can be accommodated in different shell, and afterwards you can do this calculation very easily. Now coming to the next question, how will you find the valency of chlorine? How will you find the valency of chlorine? Okay, sulfur and magnesium. Now to find out the valency of the chlorine. Now what is valency? Valency is the combining capacity of an atom of an element. Valency is the combining capacity of an atom of an element. Now in that case, which electrons go for the combination? Now what do we mean by combining capacity? Means atoms, let's take, suppose it is carbon and oxygen. Okay, this is carbon and oxygen, this is carbon monoxide. If carbon and oxygen has to react together, what is actually happening? Actually, what is happening in the case of reaction, when the two elements come together, two or more than two elements come together, they usually form bonds. Okay, they are coming together, so definitely they are going to form bonds, right? Whether they are covalent bond or they are ionic bond. Ionic bond are also known as electrovalent bonds, right? Whether it is covalent bond or ionic bond, the bonding is formed. And how the bondings are formed? Bondings are formed by, in case of covalent bond, by sharing of electrons. Okay, by sharing of electrons. So what is the role the electron playing over here? Okay, it's a very significant role electrons are playing over here. That electrons are actually making bonds with other elements and thus forming compounds. So now which electrons are responsible for forming bonds? It's the outermost shell electron, that is the valence electron. Okay, so that is why it is very important for us to know the valency of any compound. That is why we can write the formula like CO, CO2, right? O2. Okay, and these formulas are formed. We know, you know that we have formed many compounds, and before forming the compounds, we learnt the valency of different elements or atoms of different elements, right? Even in case of an ionic bond, the electrons are gain or loss. Electrons are gain or loss. So in this case, gain or loss. So is the electron, these are the electrons which are participating in forming the bond, electrons which are participating in forming a compounds, and these electrons are nothing but the valence electron. Valence electrons are found in the valence shell of an atom. So valency is very, very important. Okay, now here let's see the chlorine. 17 are there, protons and electrons, 17 protons, 7 electrons. Distribution of electrons in the shell is 287, right? 17 at 287, right? Then what about the valency? Chlorine needs, now when you have to find the valency above 4, okay, the valency above 4. Suppose there are 1 electron in the outermost shell, valency is 1. 2 electrons in the outermost shell, valency is 2. 3 electrons in the outermost shell, valency is 3. Till 3 atoms can afford to lose electron, right? 4 electron in the outermost shell, valency is 4, right? Valency is 4. But 5 electron in the outermost shell, 6 electron in the outermost shell, 7 electron in the outermost shell. In these cases, we cannot calculate the valency like this. When there are 5 electron in the outermost shell, the valency is 8 minus 5. Why I have taken 8? Because 8 is maximum number of electron that can be accommodated in the outermost shell. Any element cannot afford to lose 5 electron. No, it is not possible. Neither 6 nor 7. Okay, so in this case, valency is 8 minus 5, 3. So when this element gets 3 electron, it is getting a configuration of nearest inert gas. Okay, it will become inert. 5 plus 3, 8. Okay, then when it gets 3 more electron, its outermost shell will have 8 electron, which is a very stable state and which is similar to the configuration of the nearest noble gas. Similarly, in case of 6, 8 minus 2, valency is 2. 8 minus 7, valency is 1. Now 3, 2, 1, I can put minus 3, minus 2, minus 1. Why? Because they are gaining electron. Here plus 1, plus 2, plus 3, because they are losing electron. When they lose electron, what happens? The number of proton increases, right? So that is why they are getting positive charge. 4 can be plus or minus 4. Okay, but usually it is plus 4 because usually it goes for sharing. Okay, carbon and silicon are the two elements which has 4 valency and they form covalent bonds. Now coming to sulfur, atomic number of sulfur is 16, right? So number of proton, what do you mean by atomic number? Atomic number is a number of proton present in element is atomic number, right? Now number of proton is always is equals to number of neutron in case of neutral atoms. In case of neutral atoms, okay, neutral atom is very important. Neutral atoms, not in case of ions. What are ions? Ions are something which these are the element or the atoms of an element when they lose electron or when they gain electron. Na plus, lost electron. Chlorine, gained electron. So these are ions, right? I am talking about number of proton and number of electrons are equal in case of neutral atom, right? When I write just Na or when I write just Cl, these are neutral atom, but these are ion because it has charged. Okay. Now distribution will be 16, so definitely first shell will have 2, second cell will have 8, 8 plus 2, 10, left with the 6 electron. So M can have 6 electron because the maximum number of electron that M can have is 18, right? So here the valency, now 6 valence electron, 6 cannot be the valency, it cannot lose 6 electron. So better, what is the valency over here? Whenever there is a 6 valence electron, the valency is 8 minus 2, remember 8 minus 2, okay, which is 8 minus 6, which is 2. Here the valency will be 8 minus 7, which is 1. Okay, so chlorine will have 1 valency, sulfur will have 2 valency, and now let's see about magnesium. Magnesium, the atomic number is 12. Okay, so electronic configuration is 2, 8, 2. Magnesium can lose 2 electron. 2 electron easily can be lost. So the valency is 2, or we can write plus 2 because it is donating electron. When it donates electron, the number of proton definitely will have more as compared to the number of electron. It is not that protons are increasing. Protons are not increasing. Only the electrons are getting decreases. So the net charge is more of positive. Then here question number next question number 10. If a number of electrons in an atom is 8 and number of proton is also 8, then what is the atomic number of an atom? Now what is atomic number? Definition of atomic number, it is a number of proton. Number of proton given over here is 8. So atomic number will be 8. Simple. Okay, and then what is the charge of an atom? See, number of proton are positively charged. Okay, and here number of electron 8, number of proton 8, positive charge are same, negative charge are same, positive negative will get cross over, cut over, and the atom will be a neutral. Atom is neutral, it doesn't have any charge because number of proton are 8, electron are 8, positive negative will cut, and that's it. Next question, find the symbol of H, D and T. Tabulate 3 subatomic particles found in each of them. Okay, find the symbol of H, D and T. H is for hydrogen. Okay, D is deuterium. It is an isotope of hydrogen. T is tritium, it is again an isotope of hydrogen. Okay, now we know that what is isotope. Isotopes are the they are of the similar element. Isotopes, they are of similar element. These are the atoms of similar elements. Similar element means we are taking, I am considering only hydrogen, there is no other element. Okay, atoms of hydrogen. Okay, but what is the difference? There is a difference in atomic mass. The hydrogen gas is having atomic mass 1, right? Atomic mass is always written at the top, superscript, and the number is written at the bottom, that is subscript, right? Again, in deuterium the atomic mass is 2 and the number is 1. In tritium atomic mass is 3, it has to be 3 and the number is 1. Okay, so if we see in hydrogen, deuterium and tritium, the atomic masses are changing, that is 1, 2 and 3. So this is a difference in H, D and T. We have to write the electronic configuration of any one pair of isotopes and isobar. Isotopes, just now we discussed, these are the atoms of the same element having same atomic number but different atomic mass. As you can see here, carbon 12 and carbon 14, 12 and 14 are atomic mass which are different, but atomic number is 6, which is same. Atomic number is 6, which is same, right? And we have to do the electronic configuration. Let's do the electronic configuration. Okay, because we know that electronic configuration is based on the number of electrons, right? And atomic number, what is number of electron or number of proton is nothing but atomic number. So electronic configuration of both the isotopes of carbon will be same, right? So it's 2 and 4 and 2 and 4. Number of electron in the first shell 2, number of electron in the second shell is 6. So these the atomic number is 6. So number of electron in first shell is 2 and the number of electron in the second shell is 4. So this is how it goes. Isobars, they are atoms of different element. These are the atom of different element. See, we have taken calcium and argon. Calcium and argon are two different elements, and what we can see over here, they have same atomic mass. Here the atomic masses are same but atomic number are different. Definitely it has to have different atomic number, because see children, atomic number, it is just like a identity number of any boy or any child in the school, right? You must be having your identity number, okay, student identity number, that is unique. A student identity number is unique. Suppose there are employees working in a factory, so every employee will have employee ID, okay, identity number. Every employee identity number is a unique number given to that particular person, right? Similarly, it can also be compared with the Aadhaar card number. Every person has its unique Aadhaar card number. Similarly, every element has its unique atomic number. Atomic number cannot be same, right? So in this case, the atomic number definitely different, and even the elements are different, but they are having same atomic mass, right? Here, so because they have a different atomic number, so definitely the configuration will be different. For 20, let's see the configuration of calcium. K, L, M, N, 4 shells are there. In the first shell, 2 will go, okay, 20 minus 2, 18 are remaining. Then 8 will come to the L shell, maximum number of electron that can be accommodated in L shell 8 plus 2, 10. 8 will definitely come in M shell, okay, the maximum number of electron that can be accommodated. Here we are not considering the maximum number of electron that can be accommodated in M shell according to the Niels Bohr. We are following the octet method. That means the maximum number of electron that can be accommodated in any shell is 8. Children, octet number of octet method of filling the electronic shell is the maximum number of electron that can be accommodated in any shell is 8. 8 is or octet. 8 and octet, it has a similarity, right? So we are following the octet method here. Okay, here in argon it's 18, so 2 plus 8, 10, and remaining 8 is filled in shell M. Argon is a noble gas. Okay. Compare the properties of electron, protons and neutron. Here we have compared the properties of electron, proton, of neutron. Let's compare first the charge. Electrons negatively charged, proton positively charged, and it doesn't have any charge, no charge. Okay, no charge. And mass, electron has a negligible mass. It has a negligible mass. I will write here, it is 9.1 into 10 to the power minus 31 kg, right? Very negligible mass. And proton is approximately 1 AMU, neutron is approximately 1 AMU mass. Now electron get attracted towards positive charge, and the protons, because they are positive charge, they get attracted towards negative charge, and neutron do not get attract as they are neutral. Okay. Then electrons are present outside the nucleus. We know that they are present in the shell, right, around the nucleus. Then present in the nucleus, protons, as we know, nucleus, inside the nucleus we have proton and we have neutron. Protons are present inside the nucleus, as well as neutrons are also present inside the nucleus. Compare all the proposed Bose model of an atom given in this chapter. Okay, compare all the proposed Bose model. Okay, in fact, I think it should be compare all the models of an atom given in this chapter. Okay, now let's see the models of atoms. Thompson, Rutherford and Bose, right? Thompson, I have already given you introduction of Thompson. Sphere of positive charge, it is just like a watermelon, right? Here the negative charge are embedded in the sphere of positive charge, right? Electrons are spread randomly all over the sphere. And what was the great achievement made by J.J. Thomson, that positive and negatively charged, they are the whole atom is electronic neutral. Okay, whole atom is a neutral. So that was a great discovery by Thomas. Then positive charge is equals to negative charge, that means atom is a neutral. Then atom is electrically neutral, that what we have already done. Rutherford, sphere of positive charge in center called nucleus. So positive charge are confined to center, they are concentrated at the center, and he called it nucleus. And all mass of an atom resides in the nucleus, because we consider that electrons have negligible mass. 9.1 10 to the power minus 31 is very less, it's almost negligible. So whatever mass the atom has, it is due to the proton. Okay, this is said by Rutherford. Electrons, then what he told, that electron revolves around the nucleus in well-defined orbit, because he did the experiment with the gold foil, and Rutherford exploded alpha particles on a thin sheet of gold, and that is why you can able to see here, when these alpha particles are going through the thin sheet of gold, he found that few alpha rays of alpha particles are just going straight. Okay, in fact many rays were going straight, and few rays were deviated little bit, and very few rays are completely deviated almost at 180 degree. Okay, so alpha particle are positively charged, alpha particle rays are positive charge rays, right? So these deviations, the rays which are going through the foil, which shows that there is a lot of empty space, and the ray which is deviated at 1 degree, 180 degree, which shows that there is a positive charge concentrated at the center, and that is why the alpha rays is deviated completed at 1 degree, and a few rays were deviated a little bit. This is probably of the electrons which are revolving around the nucleus in the shell. So this is what is put forth by Rutherford. The size of the nucleus is very small because there are very few rays which deviated at 1 degree, 180 degree. So that means the size of the nucleus is very small as compared to the size of an atom, right? It is, if this is an atom, the nucleus is this big, that's it, very small, and the whole mass of atom is concentrated in this nucleus, because in this nucleus protons are there, okay, according to the Rutherford. But now we know that proton and neutron, which has prominent mass, and because of the mass of proton and neutron, the atom has a mass, because electron is, the mass of electron is almost negligible. So considerable mass of an atom is due to the presence of proton and neutron, but it was not, neutron was not discovered at the time of Rutherford. It was only proton. He thought that because of the proton, the considerable mass of the atom is there. Okay. Bohr, positive charge in center called nucleus. This is what the Bohr told. Electron revolves in discrete orbits and do not radiate energy. So what was the limitation of Rutherford? Rutherford told that electrons are, if this is a nucleus and electrons are revolving around the nucleus, then what happens ultimately? Electrons are revolving around the nucleus, and while revolving around the nucleus, it is radiating energy. But when something radiates energy while revolving around the one particular thing, then this energy will be radiated, and this particular electron will left with no energy, and finally it will go and get fuses with nucleus. So this was the drawback. This practically doesn't happen, because if it would have been happen, you won't find so many atoms around you, because then the life of the atom will be for it will be for fractions of second, that's it. Okay. So practically it wasn't proved and not possible. Bohr told that they are moving in a discrete orbit, they don't radiate energy. This is the great thought put by Mr. Bohr. The orbits were termed as energy shell, labeled as KLMN or number as 1, 2, 3, 4. For today's session, thank you so much. The rest of the question we are going to do in the next session.